This one is continuous motion, and this also continuous motion. It will just ignore this point and directly go this way. Okay. 3 points. And this is the motion path. If let's say we put a continuous motion here, CONT at point 2, then it moves, it will go this way. And how do we define the curvature? We have 2 parameters, acceleration and distance. 0 to 100%, and this is 0 to 300. But physically, how this is being defined, I'm not so sure, because after trying for so many times, still I cannot get it. And from the note, what I see is that it seems like an approximation. So it's kind of try and error when you try to move it along the curves. The reason why we want a continuous motion is that we have 2 reasons. This is a velocity profile. Okay. Let's say start from point 0. This can be a time or it can be a distance. So moving to point P1, you will start picking up the speed and constant speed, and when it's about reaching point P1, you will slow down, and then you'll stop for a while before it starting moving to point P2. So this is this start and stop motion is mechanically not desirable, because we have inertia, starting of motion and stopping of motion. You need a lot of energy, currents, everything. It's not efficient. Another reason is that we want to reduce the cycle time. By choosing a continuous motion, we can eliminate this delay. So it will be something like this, and we can save this amount of time. So it's a cycle time is good for cycle time control. Yeah. Alright. Choose cancel 7. Okay. Now open it using open, and go to the desired point and add in the continuous motion.
15.
Okay. Change.
Do you need to change the key?
Choose Okay, so move your cursor to this column. This one.
Continuous.
And you can see by moving your cursor to this column, this is how we set the acceleration and the approximate distance. But in this case, we just leave it as default. So touch up or command OK. And this point, continuous motion. And wait for. Waiting for something to happen. It can be a switch, or process, and we're having inside this we're having 4 items: out, pulse, synchronized output, and synchronized pulse. Out is an output. For example, if you are having one line of program, let's say point 1, blah blah blah, point 2, and let's say point in between point 2 and point 3, you put an out. So after point 2, the output will be executed. It's independent of time, say delay, and it's independent of process, which is a path. Okay, and we're having a pulse. A pulse is an input in this way. We specify the time. Likewise, it's independent of time and independent of process. In synchronized output is time and process dependent. This one also the same. The difference between them is only that a pulse is this way, then we can specify the time. But an out, we cannot specify the time, it's just an output. So this is the basic of logic programming.